I now request the Senior Sales Manager for Europe at Huasun Energy, Anna Paskaleva, to please share her presentation. Anna, welcome to TaiyangNews.
Hello, everybody.
Hi.
I hope can you hear me well? Is it better now?
Yes, it's better now.
Okay, so thank you for the opportunity to share with everybody what we have been able to achieve at Huasun. As you well know, Huasun is the leader in heterojunction technology development in the world, and 50% of all heterojunction products on the market are actually made by Huasun, which makes us really a serious player on the market. I will focus right now on my presentation the company's introduction shortly, some information, one example of the most recent and actually the biggest project of HJT being developed in the world right now. So as you know, Huasun right now is one of the leaders in the heterojunction technology and a pioneer in developing this type of technology. Right now we have an annual capacity of 40 gigawatts per year, distributed in 5 locations in China. And we ranked on top 3 in TaiyangNews in terms of module, in high power module
Anna,
ranking. Yeah.
Anna, your
Sorry.
voice is not very clear in between. So can you please switch off your camera and then try? Maybe it's taking the bandwidth. So
Okay. So generally, what we compare with is HJT compared to TOPCon. This is the key two technologies on the market that we are discussing. And in terms of reliability, temperature coefficient, power degradation, HJT has proven once and again that it's superior technology compared to TOPCon. As of now, we have been able to achieve a low temperature coefficient of 0.24% per degree Celsius. As you know, and most of our viewers may be are aware that with a higher temperature, the power output of the module goes down. So this is the way to control this diminishing of the power output to minimum as possible. And that's why many developers in hot climates actually prefer HJT right now, as they are able to keep to minimum the power degradation of the module and the power output degradation. And right now we are focusing on 4 main sizes of cell development, and they lead to 4 streams of products. This is the G12R residential module, the G12R for rooftop and CNI, and our G12R for some larger CNI projects, and as well as, of course, our G12 132 cells modules. And I will talk a little bit between the differences between the two main. I will talk about the differences between the G12 cell and the G12R. Basically, the size of the cell is what makes the biggest difference. And the G12 originally, the G12 132 cells that we use in our biggest solar panel, they are specifically made for utility scale solar modules. And now recently we have started to develop G12R to satisfy the needs of the residential market, because we see that with this cell we are able to achieve a lower current and minimize the losses. All right. And this is the 2 main products, the two mainstream products that we're focusing on, the G12R-132, as I mentioned, and G12R. This is basically what we're working on, just to cover all the needs of the market, from residential C&I to utility scale. And here I'm going to focus my attention a little bit more on the LCOE part and how to show our final customers that they're basically maximizing the investment that they're putting into any project by using HJT technology. Since we are comparing HJT to TOPCon, we are talking now about an HJT product of 460 watts compared to TOPCon 430 watts, but the size of the modules is the same. And we're talking about an 11 kilowatt installation using HJT compared to 10 kilowatt installation using TOPCon. Keep in mind that what we have kept is the same number of solar modules in each installation. Basically, we are able to see that with the same amount, with the same number of modules, we are able to achieve with HJT modules, we're achieving 1 kilowatt more. And we are maximizing the energy yield with up to 8.7%, which in long-term calculations results in much higher return on investment for the final client. And we have several projects to derive this information from. This is another C&I rooftop installation that has shown more than 10%, almost 11% of actually more energy yield of HJT module. Again, using the same number of modules. At the utility scale right now, we have up to 3.2% higher yield by HJT. This is an example using our recent 210R module. And this is mainly has been achieved thanks to the lower temperature coefficient of the HJT solar cell and the higher bifaciality. Those two main specifications are what has given such a competitive advantage of HJT compared to TOPCon. And this we see on the spot on many locations around the world. We are receiving a very positive feedback from our clients, basically saying that now what they have realized with HJT, when they have realized the potential that it has and the benefits that they bring, they're saying that all their future installations are going to be made with HJT modules. And talking about balance of system, BOS, as our audience know, this is all the other components going into one system, except for the solar PV panels. So additionally to higher energy yield, because of this higher performance of the HJT module, our clients are able to save from the rest of the installation equipment that goes into one system. This is the racking. You need fewer elements in the racking, since the number of panels is going to be to achieve the same number, the same capacity of installation. For example, HJT and TOPCon, you're going to use fewer modules. HJT. If you're going to HJT, you're going to use fewer modules. If you compare to the case of TOPCon. So in this case, it's logical that you're going to use less racking systems. Also the land use. This is also crucial, especially for locations in Europe, where we have a lot of limitations in terms of land use. Places that agricultural land is being protected and you're not allowed to make installations on the agricultural land. or in cities, if you're able to use only the rooftop of the buildings, of course, you're going to try to maximize this surface area that you're allowed to use. So in this case, to maximize the user blend, your best choice would be HJT. As we see, this is in my presentation, we're using mu for land land square surface, which is used in China, but it can be any type of measuring unit. Just the important is that you're saving up to 4.8% per land use. And when I say up to, I need to mention that we are doing those calculations on a very conservative basis. So this is the most conservative outcome that you may get. In reality, what we get from our clients is even better data from real-time experience what they're having with their project. Sorry. And I will talk about this later on in my presentation. Another point of the BOS, this is the cable usage. And as we're going to use fewer modules in the case of HJT, we're going to also save from cable length. We're going to be able to balance the AC and DC cables, and being able to save up to 9.3% in DC cables and 1.4% of AC cables. Again, this is a very conservative estimation. This is an overview of all the BOS costs that you're able to save, balance of system costs that you're able to save from in building your system. This is the module installation cost. Since you're going to use fewer modules to achieve the same capacity of installation, you're going to use less labor force. The racking, you're saving from racking, mounting systems, the land being used for the installation, the cabling, the grounding, as you know, for the grounding of the modules, you also use less materials and less work since you're dealing with fewer modules. And overall, we're estimating that this would result in around 3 renminbi cents. This is the Chinese yuan cents per watt savings. And this is an overview of the whole LCOE cost. This, again, very conservative estimation, up to 2.6% compared to comparison between HJT and TOPCon modules. And a return on investment up to 3.9% more. This is some scenarios that we have been able to track. A desert installation in Gansu, China. As I mentioned, with the higher temperature, the power output of the module goes down. So in this case, with the highest temperature of the area, we've been able to sustain relatively stable power output during the day. And also, if you are able to show global comparison, global map comparing HJT versus TOPCon, you will see that in the most the areas closer to the equator, where the higher temperature is, you have the highest differences in the power output. So in terms of HJT being better than TOPCon, the hotter the climate, the better the most obvious the difference between HJT and TOPCon is. And in this case, also the faciality of the HJT technology is a main contributor, as I said, not only the temperature coefficient, but the faciality. It's allowing us to get a higher yield by increasing the power output also from the backside of the module. And these are also other BOS costs calculations of how much our this project has been able to save using our technology. I'm going to, this is also again in Saudi Arabia. I don't want to focus too much on those slides because what at the end it results in is always a better number of HJT installations compared to TOPCon. I would like to show one of the real results that we are able to see with this project, our biggest project up to now. This is the Aprilti project in Bulgaria, which at the moment has an installation of 650 megawatts installed and connected to the grid. The project is using entirely modules manufactured by Huasun. And the developer has signed already that's 1.5 gigawatt. This is the framework agreement for developing future projects in the area using exclusively Huasun HJT modules as well. We're working now with data provided by the developer, by the project owner, and they're testifying that the use, sorry, this is not very visible here. This is 1,850 kilowatt hours. Data provided by the owner, saying that this is much higher than what they have expected, even taking account that this is a new technology, HJT technology. They have been able to achieve a much higher yield than expected. The estimated, this one in blue, this I need to mention that this is based on calculations of PERC modules. So this is, we're not comparing TOPCon with HJT, but this is what initially the customer was planning to use PERC, and then they completely shifted to HJT. And they're dedicated into developing their future projects with HJT as well. Also, the blue one is fixed axis, fixed mountain structure calculations, and the one that actually the client has is with trackers. So this also adds to this 32% difference. So we're not just comparing actually just the cell level. Based on the geographical area, this is what is basically being expected by PERC fixed compared to the actual, which is HJT tilt tracker, tilt installation. And in any case, the customer has been really happy with the result and is really planning the rest of the projects to be developed exclusively with our modules. Need to mention here that they're using the oldest project, the oldest product. In this project, they're using the oldest model that we have, the N6, which now we're phasing out. And we have, as you know, the G12 and G12R solar cell, which is much more efficient. The project here is built with our oldest, the first model that we have. So taking account that if those modules were now to be magically switched with our latest one, the result would be much better. There are other projects in other locations that we can account for, and also some projects that we are developing with some of our partners using HJT modules, which are installed vertically. So this doesn't make much sense if you are trying to maximize the surface area. But there are some cases that you need to utilize the land. As we see in agricultural land, it's difficult to make installations. In some places it's forbidden even. But the high efficiency of the HJT technology allows for this vertical installation to have enough energy yield that it makes the project viable. That there is meaning in installing this kind of fence, this vertical position modules, because the HJT maximizes all the sunlight that is coming, that is touching it, that's touching the surface of the module. And also I need to mention that in Nordic countries, in Finland, Norway, we also have clients that are actually doing this rooftop installation, vertical installations. And in 6 months of the year, when the sun just pops up above the horizon a little bit and ducks down in the winter time, the sun rays actually hit the modules directly under an angle of 90 degrees, which works very well for this project, for a client, even if it's for a short period of time. So it does make sense for them. This is an overview of our project, and basically this is how I would like to finish my presentation, and would like to discuss any questions that you may have. Thank you.
Thank you, Anna. Thank you so much. That was a very nice overview.